We're going to talk about Internet of Things, and mainly I want to have fun. So if you guys want to stop and yell questions, I can go in a million different directions, and I don't mind any questions or just fun comments or anything you want to say is all great. Here's an agenda that we're not going to talk about any of that stuff, so don't worry. Maybe a few things. And as you said earlier, I'm a Microsoft Regional Director, and there's 150 regional directors in the world, spread in 50 countries, and we go to the summit at Microsoft every year, and they like tell us what they're releasing, and we give them feedback and advice, and kind of have to sign NDAs, and we're not allowed to talk about anything, but in March I'll be going back to the summit again and have a good time. I'm a graduate from NC State up in Raleigh. I don't know if anyone else went to State, but love it. We've got a bunch of kids, one at Carolina and one at App State. They're both doing really good. I don't even meet much of advantage because we were sold. Meet Pratt Miller. So this is the first talk I've done wearing a Pratt Miller shirt. I'm really stoked that we sold our company, and we're going to be doing like really big things. Pratt Miller has like 300 and maybe 30 people, and we were a small company, around 30, and we're all software. They're all engineers, and so with the Internet of Things, things are exploding, and we've got now a team of like tons of engineers that are doing autonomous vehicles and big projects for big companies, General Motors, Department of Defense type companies. And now we've got all the software capabilities and engineering, and really primed to do like awesome stuff. What is IoT? That's a slide with a bunch of stuff on it. But here's kind of what IoT is. This is something I made several years back, but I can never remember to take my medicine on time. And so I made this little device that sends a text to me at 9 o'clock after I forget my medicine. Or if I remember to take it, it won't send the text. But then a second one at 9:30 or 10, I forget how it's programmed, will send a second reminder. I say, hey, stupid, you forgot to take your medicine. And then when I take it, it logs in the cloud the time I took it. And then you can see a record of like how good was I at taking my medicine and things like that. But so I did this really cheap. This is the $19 microcontroller, and that's what's driving the Internet of Things, are these really cheap microcontrollers. There's Wi-Fi and everything on this, and for this one and a lot of others, I'm using a company called Particle, and Particle has done really great in the, especially in the makerspace. They've made it really easy to do IoT, and now they're like making newer features and really growing into the enterprise space. We've done some really cool projects using some of their stuff I'll talk about later, but if you guys want to learn, yeah.
So are you breadboarding that, or are they print?
So on this one I just put a little breadboard on it. It's down, dirty, and simple.
Yeah, okay.
It just works. So you just give it power and it's on Wi-Fi, and the way this works is there's a switch right here. So when you push the switch, it just sees that you unlock it. So it doesn't know you actually opened it. It just
or
knows
what day you took it, right?
Yeah, it knows what time you unlocked it, and then sends a message in the cloud. You can do with it whatever you want. Makes it simple. So yeah. So I like to have fun with IoT, and as you can see with Halloween, every year I make a new monster, and I think it's maybe 8 or 9 monsters, I can't even remember. We've done some really epic ones, like there was one in the coffin that used the Microsoft Kinect that senses the kids as they walk by, and it'll turn its head and track all the kids. And there's a whole bunch of other monsters that do things based on where the kids are. There's like a glow-in-the-dark bracelet you reach for, and the Kinect sees where you are, and it sends 110 pounds of air. It's like a punch in the gut, wake the kids up, and then it makes like a huge noise in the yard. And everything in the yard then reacts to the noise, and it looks like there's a whole bunch more IoT stuff. But there's really like 9 or so things that I've connected. And one of the really fun one is Fire. And Alexa-controlled Fire, where you talk to it. And I made this 12-foot monster that the kids will talk to, and it shoots the fire over their heads. And I thought that was like super safe. It's 12 feet tall. How can anyone get hurt? And then one kid tries to climb it. So, yeah.
Let's look at his face, see what's in there.
Yeah, so the next year I got a better idea. It's like fishing line. We'll hang it from a tree. And so the year before last, a friend of mine from Charlotte IoT, we 3D printed this device that blows fog bubbles. So we got a computer fan and we 3D printed it, and it dips the spout into a bath of fogs, comes up and just turns the fan on. We actually use a vape to make the fog, like what people smoke with a vape, and control the voltage on it to get the right amount of fog and blow through it, and it makes these really cool bubbles of fog. I'll show a video on that. Actually, let me go ahead and do that before I forget. I don't know why my computer, I think I'm out of hard disk space or something. It's really slow. I think it's the host machine, not the VM.
And now here's the fog. Here's some fog bubbles.
Is that standard fog juice?
Yeah, so we went to Walmart and bought the $10 fog juice. You can put baby juice in it too if you're rich. There's no need.
So what's setting it off?
So it's Alexa control. This thing is, I'll show you this goes in just a second. But the kids talk to it through Alexa, and it makes it go off. Everything's battery powered. There's the Firebreathing Monster. So if you guys want to make one of those, we put all the code on Hackster.com, I believe. It might be IO, I forget what the end is, but we'll put it on Hackster. And Hackster is like an amazing company. They've given Charlotte IoT like tons and tons of really cool swag that we've done all kinds of workshops on and things like that. And then our civic hacking we do with Charlotte IoT, we post the hardware on Hackster, and we have a Git repository for the software. And so Hackster's like a really good company, and if you guys want to make one of those, you can get all the 3D models and everything. But Mark and I came up with that design and built that. It was funny because Mark probably spent 60 hours on the actual machine, the 3D printing designs, and every day he'd come up with a new iteration. And with it being 3D printed, we were able to like go through the designs really quickly. And I probably spent 20 hours on there's an Alexa Lambda functions that, and I'm using the Alexa Skill Kit API to send the messages down to the microcontroller. And I've got maybe 20 hours into it. This year we just sold the company, and I've been working like crazy. And so I spent like 2 hours on this. And but it's still like really cool, and I'll show you what it is. Alexa, trick or treat. That's all it does. But so I went to Lowe's and I purchased the Ghost, and all I did was replace the microcontroller in it that's listening to a message that I'm pushing out through the smart home API with Alexa. And I'll wait for that to stop.
Sorry, I don't mean that.
You use the A word. We call it the A word.
Yeah. I've got some like multiples in each room, and if you want to talk to one, you have to, yeah, Gary.
Your last meeting with Gogol was pretty impressive from the standpoint programming language is almost, you know, just normal language to do things, you know.
Yeah. Yeah.
So we've come a long way.
Yeah, so it's amazing how easy it is to, like this whole thing, I got home from work one night at like 9 o'clock and I was doing a talk in Raleigh and I always bring my Halloween stuff to it. So in 2 hours I literally put that together and then went to bed. And luckily it worked. You always have to kind of cross your fingers. But the reason is because I leveraged code that Charlotte IoT wrote. Charlotte IoT has an awesome library that we've done with the Civic hacking that uses the Smart Home API with Alexa. And so Alexa has multiple ways to integrate with it. And the Smart Home API is the hard one. But it's what you use to like turn on a light or something like that. Otherwise, you have to say something like ask Alexa to, and then you have your intent and she'll invoke the intent. And it's not as natural speaking. And if you use the Smart Home API, then you can write routines, and with routines you can change what the trigger word is. And so that's how I made it be the trick or treat to make that go off instead of turn on, and then the name of it is how that works. And so I kind of had fun with that at home, and I was trying to impress my wife. And I'm like, hey, Alexa knows who I am. So I'm like, hey, honey, hey, Alexa, who's Dan?
The smartest, most sexy man alive. He's also a really good dancer.
So I did that to impress my wife, and then I made one for her too. It's like, Alexa, who's Kim?
Kim Thayer is crazy as hell, but a true Southern belle. Kim is the luckiest woman alive. He is married to Dan Thayer, my creator and otherwise known to his family and me as master.
But yeah, Alexa's just like really fun to play with, and if you guys want to see code, I can show you guys some code for how all this stuff works later on in the talk or even after the meeting. It's all really fun. So yeah, that's just using the routines. You can do simple things like that with very little or no code for the routine.
So are you putting this in your guest network?
My guest network, yeah, it's my hotspot is my phone.
No, I mean like at home.
So yeah, so, he brings up a good point because all this IoT stuff, some of it is pretty hackable. And so you're going to want to segment your network. You want to have two networks, one for your devices and then one for everything else. And that way if someone hacks one of your devices, well, they can use that as a denial service to attack somebody else, but they can't really attack you very easily. And that's a smart thing to do. And also just kind of don't expect to hang on to your stuff for that long. People buy things, they're real proud of it, like a video camera. And the security on the old cameras are really, really bad. They're really, really easy to hack. And so throw them away, buy something fresh. And make sure that what you buy has the ability to update the firmware on it so that they, you know, like your PC can update the firmware. And if the hackers learn something, then you can try to defend against it. And you need to make sure your IoT has some of the same capabilities. And the stuff you bought 5 years ago doesn't, so go ahead and throw it away and buy some newer stuff. And just like a cell phone, you don't hold on to your cell phone for more than 5 years. Yeah, Gary?
Do you have a ring, and if you do you spray them with water if they don't leave?
I do spray people with water, and I've got a great Alexa command. I don't know why she's not even going off, but at home I say her name and then make it rain, and I've got a squirt gun that I built. And the squirt gun, you can target on people, but if you make it rain, it points the nozzle up in the air, and it shoots like 30 feet up in the air, and it comes down these drops of water everywhere. But yeah, so I don't have a ring, but I do have a camera out there. I just haven't bought the ring yet. Most of the stuff that I have at home is all stuff I built. It's not commercial stuff, so I'll start with usually a particle photon and then extend it from there.
You could probably make a fortune making one of those that would kind of get that dog that keeps hitting your lawn in the morning.
Yeah. Oh, to have it target the dog?
Oh yeah, squirt the dog.
Yes, that actually
better
wouldn't
get
be
the
too
guy
hard.
walking the dog.
Especially early in the morning because there's not a lot of infrared light.
You can track the dog too.
You can track the dog and figure out, you know, this is a dog and let's... Yeah.
Target ceasefire.
Yeah, it's amazing what you can do dirt cheap, just with some passion. So Particle, I've mentioned them a few times, but they just came out with their 3rd generation stuff, and their 3rd generation has a mesh on it, and they have 3 different types of microcontrollers. Actually, let me go ahead and start to load that. I should have done that for the talk. It's just really slow, so I'll just keep on talking once. It's fast, making me a liar. Okay. So one really cool thing about Particle is they've got our logo on their homepage. Yeah, so they also wrote up a case study on one of the projects that we did. And we're real good friends with Particle. But beyond them just being cool and having our logo on their homepage, they changed it around just a hair. That's not what I want. I want the mesh. Okay.
Now, when they say secure by design, that doesn't mean non-hackable, it just means it's hardened, right?
Yeah, I mean, a lot of this stuff. Okay, so if you want something that's really secure, you're not going to do it at the price point of Particle.
You can't get really secure for $20.
No, yeah, you're going to have to spend like $80 and go with like Azure Sphere, and they have open sourced the silicon, and they paid the first company to make some prototypes and to make the first units, but it's all open source. So the goal is to have others making the same silicon that knows how to talk to IoT Hub and connect into Azure. But it all starts with the silicon and how you store the certificates, and but you're going to pay a lot more for a solution like that than a Particle solution, which they try really hard with security, and they do like better than a lot, but it's a whole other layer. The company who purchased us, we're doing work for Department of Defense, and so we'll use like a Azure Sphere for that. And there's 3 components to Azure Sphere. It starts with the silicon. They also have they're running a Linux operating system, believe it or not, on the device. And so it's like one of the first times Microsoft's pushed out Linux, but it's really good for IoT and for doing what they need to do with security. And then they also have the cloud component and IoT Hub and to ingest everything. So that's a really good solution for security. Yeah, Gary?
No, just thinking.
Yeah, but the mesh stuff is like really sweet. So who here's got Nest at home? Yeah, maybe everyone knows what Nest is. Google created this technology when they built Nest, and it's Thread, and Thread is a way of having all the devices route messages from one node to another node. And if you lose a node, then it's smart and it figures out something else will become the router and will route the message. And so you're like guaranteed to get the message to the nodes that you want if you have enough nodes in your network. And so it's really good in manufacturing. We're getting ready to do a solution now where we're having a bunch of devices, and then we have one central node that's the gateway, and the gateway can either be Wi-Fi or cellular. And they've got these 3 products, Argon, Boron, and Xeon. The Xeon's the dumb one. It's just a node that has the radio. It's got a Nordic semiconductor chip in it that is the open thread part of it. And then there's the Boron. I always forget, is that the Boron I think is Wi-Fi, and the Argon is cellular, or maybe the other way around. But one's cellular and one's Wi-Fi. And so what's really cool is you can make these devices like the medicine thing that someone has, and you can put it on cellular, and that way if you're traveling, then it still works. And I've got this like tweet shirt that I bring to conferences and have to connect it to my phone. If you tweet me, the shirt lights up, and but it'd be really cool just to pay for a data plan, and the data plans are really cheap, especially with the 3rd generation stuff. And then you don't have to worry about Wi-Fi anymore. You can make a product that's already connected. All right. So there's a bunch of crap out there. I'll jump past some of the academic slides. And Industry 4.0 is really important, and we're doing like really good projects for manufacturers, and the same technology that like people are doing it for home, you can apply to a manufacturer. And here's an example of one we did. I'll talk about it more, but it's for a thread company, and they're in Marburg, which is like halfway towards the beach. And they wanted to know, like their plant, they have 3,000 of these spindles, and they want to know what's up and what's down at any given time. They want to know things like, well, how's my utilization during breaks? Or if we run third shift unattended, how good is it? Things like that. And they always had people with clipboards, and they would write down the information, and they'd always get like partial information. They get some good information, but not really accurate information, and they didn't do a great job of tracking it, even though they were all trying to. And so with like a solution like this, every minute we post each spindle up in the cloud and in Azure, and then they know exactly what's being utilized and not. And that's how they found out that their clipboards that they were doing weren't as good as they thought they were. And they can make better decisions, like, is it time to buy more equipment? Is it time to put extra staff on it? Or if I do a zone here with more people here, how does it impact things? And then all of a sudden you have all this data in the cloud, and you're like, what else can you do? And a while ago we wrote a mobile app for work orders. When it breaks, we know when things break, we know what breaks. We can start to correlate like what broke on the machine to the utilization of when the machine's being used, and then it can do preventative maintenance, predictive, to tell the maintenance guy to go fix it, before it breaks, that type of thing.
Is that doing more than just rotation?
No, this just spins. It was really boring to watch.
No, I'm saying, so you just put the sensors on the existing spindles?
Yeah, that's all we did. Is well, actually, we didn't even do that. So the existing spindles already had sensors on them. The PLC already knew this information. But the PLC, some of them were as old as like World War II. They weren't connected. And some of them were like brand new, like really cool machines. And so we could have integrated with 24 different styles of machine, but instead we made a PCB board that we just wire the same inputs that are already going into the PLC. We just wire them into our board. And for this is like an $8 module here that's got Wi-Fi and the particle microcontroller on it. We post the data up in the cloud, really cheap, and then it works on every machine. And it doesn't require software guys to do an integration 24 times for each new machine. They can buy a new machine and just wire it up. And all the machines have like a terminal strip in front of them where all the wires come in. So it's really easy just to wire it into the terminal strip. And they got their labor who does that is like really inexpensive in Warrenburg. I was like shocked. They're like less than $20 an hour to do wiring something like that up for a skilled trade. And like a software developer, it's expensive to do all these integrations. And that kind of takes it all away and makes it like a hardware issue. And then like for support, we don't want to do support. And if something breaks on it, this is $50. Like, throw it away. Or hit reset. If reset doesn't fix it, throw it away and put a new one on. And so that's what keeps them from calling us, is how cheap they are, and just keeps them in the backlog. Yeah.
How robust are those environments? I mean,
yeah. So people
cold, hot.
Yeah. We haven't had any
dusty.
issues. Yeah. So it's been in the environment for a year now. It's inside a control panel with next to the
case.
Yeah, it's right next to the PLC, and the client actually wants us to make a case for it to make it look less hobbyist. But I love it like this. It looks like we're like barbarians just putting some shit in the control panel that works, and that's and with it not having a cover on it, it keeps it cool and things like that. It's like actually. The cover, it makes it work better. But he's thinking about selling this to others, and to sell it to others, he wants it to look less like a barbarian. But I like the barbarian. That's why I got the beard going on right now, at least.
How many of those devices do you have in the plant?
So it's on 24 right now. We've just been collecting data for about a year, and one piece is the technology has changed a little bit to where this one here is all Wi-Fi, but now there's mesh, and mesh we think will have better, and the mesh stuff just came out in October, will be better for the factory without a whole bunch of different devices connecting up to it.
This mesh, is that like, I don't know what that is, but is that like where all the devices communicate with each other?
Yeah, so mesh is awesome. So it's IPv6, and so it can do internet protocol on it, but they have a mesh radio, and so they all can relay the messages, and then there would be a gateway device that then sends it up into the cloud. They all talk to each other through a technology called CoAP, which if you guys have heard like MQTT, it's similar to that, except for it's not a whole bunch of publishers and subscribers. It's like you're sending it to an endpoint, and it'll route it to the gateway and up to the server. Did you about to say something? No.
Mesh would be much more reliable in the noisy environment.
Yeah, right. Yeah.
Well, it also means you don't have to deploy wireless just for those devices. They don't have it.
Yeah,
Right?
yeah, yeah. Yeah, and the mesh stuff, if it's in open air, it can actually talk through a football field. If it's not in open air, like in a factory, they advertise like 100 feet or something like that. We'll see, because we're doing a project now. We'll see how good it is. But they are a little bit slow on the shipping. We're supposed to get our stuff in October, and it's November now. We haven't gotten it yet. That's pretty typical, though, for a lot of the IoT stuff. They always miss their dates on shipping if you're using the leading edge stuff. But once they get caught up, they're just amazing and awesome.
I was also wondering about the interference. There's a lot of interference from the machinery.
Yeah.
That's what makes the mesh better, I guess.
Yeah, it's real resilient. So if there's like a motor that's disrupting this one now, then it can route the message through a different one. And as long as you have enough nodes in the mesh, you'll make sure that everything can
Pretty
talk
huge,
to it.
huh?
What's that?
That's pretty huge, huh?
Yeah, it's really huge, and it's awesome. Like for Christmas in my yard, I've got everything that's all on Wi-Fi, and I'm like really stoked to get the mesh stuff if I can get it shipped to me in time for Christmas. Because like the edge of my network, Wi-Fi doesn't reach out very good, and my Christmas balls on the edge don't always light up when they're supposed to, because they lose like Wi-Fi connection, and this will eliminate that problem. But you can still talk HTTPS, it's IPv6, and like that full stack of web goodness that we're used to dealing with. Internet is all built into it, and it's thanks to the Nest was the project that initiated it, and then there's the Open Thread Alliance, and there's a whole bunch of open source companies or companies that are supporting the open source initiative. I think there's like 70 or so of them. But Particle is one of the first ones that are making like microcontrollers that you can buy that are on a platform with the mesh built into it. If you want just the mesh, though, you can. The Particle has like the microcontroller, but also has the Nordic system on a chip on it, which is the radio and the mesh part of it. You could just buy the Nordic piece and then put it on your own microcontroller, but Particle just makes it easy, and they combine everything together. And the other thing they make really easy is over-the-air updates, which means I can push code from anywhere. As long as I got an internet connection, I can update the devices. Like for this project here, one time we lost a shift of data because it couldn't connect to Azure, and when it couldn't connect, it just hummed. And so we updated the firmware so that next time it gets hummed, it just does a reboot. And then we don't lose a shift of data, we lose a minute of data or something like that. But we didn't have to drive a Lambda to push that update, and we don't want to have to travel anywhere to do this stuff. And like at Christmas time when I'm doing my decorations outside, like the first time I noticed it was this miserable winter day where it's raining, And I'm inside the house next to the fireplace coating the Christmas tree outside. And I don't have to be out in that miserable weather. And so
Where's your house?
it's near South Park. But come to my house at like Halloween is really fun too, Christmas too. But I like the holidays. They're fun. Every year I just add one more IoT device to it, and for each. It's kind of been my thing now for.
What street? I live in South Park.
It's Hollow Tree Court. It's near Providence.
Okay.
Yeah.
You've seen
Or
Hillside.
Carmel. You can get to it from Carmel.
You've seen Hillside. Hillside's got all the stuff on
I haven't seen that, but yeah, I love going out and seeing all
it. Big time.
the Christmas stuff. So there's like tenets of Industry 4.0, interoperability, so that it can talk to anything. It's like we made this device so we didn't have to integrate with 24 different things. And one of the other tenets is information transparency. That's knowing like what's going on in the factory. They're going to have 3,000 of these spindles monitored, and they want to know the whole factory of what's going on. Technical assistance, like having it make decisions and helping people, and decentralized decision making. You can make decisions on the device. You don't have to make it in the cloud. There's lots of places you can make decisions. So the device can have a brain. You can have an edge device that's the gateway that is making decisions. And all the main companies, Microsoft, IBM, AWS, they're all building these IoT edge devices. And these edge devices, you build a machine learning model up in the cloud with your big data. But then to execute, to make the decision, I want to predict, is it time for me to do something to this machine? You can do that on the edge. And all the main platforms all have that today. So, I forgot my joke. So, what's I5? This is what I5 is coming up next, I4. And we already talked a little bit about Azure Sphere, but if you guys are doing anything that you need to be secure, then look into Azure Sphere. You'll pay a little bit more for it, but the hackers won't like you. So here's what this looks like in the factory, and this is the original prototype. It doesn't have here's what the PCB looks like. But this is just a board that is like a prototype board for particle, and these are optical isolators. It's because all the inputs are 24 volts, and particle, we like things to be 3.5, 3.3 volts or 5 volts, and so we put the optical isolators in so we don't fry it. But when we built the PCB board, we have all the optical isolators built into it, so there's a lot less wiring, because here you had to wire from the input and then the input two wires.
So it's an isolator step down or just recent?
So all an isolator does is shines a light, and then you receive the light, so it just knows if it's on or off. And they can switch really fast, because these things are spinning like really, really fast. And we did a prototype. We got a drill, and we made a device that was turned it into this. It was going really fast, yeah. And the first proximity sensors we had, the switching speed wasn't fast enough, and we had to get some. We found out the ones on the machine actually had like a much faster switching speed, and that made all the difference in the world to where we could count the pulses.
So what kind of rotational speed are we talking about?
Oh God, I can't remember. It seems
talking thousands.
No, it seems like it's 600 RPM or something like that.
So long.
Yeah, it's pretty fast. So you can tell this is like an old ass machine that this is on. This machine is World War II vintage, and they upgraded it many years back with one of the PLC, one of the small ones. But and then we just tie into the same inputs from it. Made it really easy.
You said before, like whoever you worked with on it, they were talking about in case you go and maybe work with you to resell.
Yeah.
You thought about replacing, the actual sensor that's doing that too? As part of
No, because the sensor costs money, and so we made it so that it can talk to 3 different types of sensors on the machine.
Sure.
Almost all the sensors are like the proximity switch, but there's 2 other types, and one works like a mouse where there's an optical thing with going through a light that shines on it, and it works actually in the end real similar to a proc switch, either is on or off. But you can program them a little bit, and we talked to that, and then a simple limit switch. So it all wires into the same inputs, and it can handle all the different types. And then in the code, the machine's configured what type of sensor is it, so it knows this one's normally open limit switch, this one's a proximity switch.
Are you, Mom, you did too, are you actually doing analytics on their data, or are they doing something?
Yeah, so we have some very basic reports that are using for like operational type things, but and I'm also, we are using PowerBI and the streaming analytics, which is crap. But we can make some dashboards with some gauges on it, and you can see information about what's up and down, but it's very limited in what you can do. I know it's going to get way better, but I've been waiting on it for over a year to get better, and it's still crap. But it will get better. The streaming analytics is all part of, like they want, Azure wants you to get their data in Azure, and so Microsoft is going to have a huge push to make that great, and I'm just waiting on it to get great. So we actually wrote something to replace the streaming analytic visualizations. It just we charted using Angular and using some JavaScript libraries. And, it connects through IoT Hub through the WebSocket and can do real-time visualizations much better than what you get out of Power BI. But Power BI it's good in respect that end user and business people can configure it to a degree. Alright, so here's what it looked like when we had the drill on it. And here's an example of, so we used the particle microcontroller and the proximity sensors plugged into it. It's talking to the particle cloud, which then talks to Azure IoT Hub. So I almost didn't want this solution because of this double hop, but we ended up being real reliable, and it was really easy to code that way. But if the performance was less than a second or something like that, it's like instantaneous. We know in like a second every false macro happens up in the cloud. If the performance weren't great, then I would get rid of the particle cloud piece and talk to IoT Hub directly through MQTT, but we just haven't had to do it because the particle cloud made it easy. We already have the cloud to do over-the-air updates, so we're like, we'll just use it, and it ended up being a great solution. But here's the over-the-air updates piece, which is key to the solution of being able to update code. For any IoT solution, you need to be able to update code. That's like, if you don't have that as part of your platform, what are you going to do when you need new features? And
where do you host binaries for IoT?
So Particle, you do it in their cloud, and their IDE is like web-based. You can update the code, and then they make the binaries and put it up in their cloud. So if you're doing it yourself, you have to like make sure you've got enough flash for the binaries that you can replace the firmware plus the existing firmware. So you need like twice the flash on it, and then you load it to a bootloader and you swap it out. And you can code it all yourself, but you're looking at some time and some effort to do that, where Particle's already figured all that out and makes it easy. But it's all dependent on what your solution is, and you know, if you're not using Particle, then you're going to have to code it yourself. But the Particle cloud hosting is like dirt cheap. For like the 3,000 sensors, it's only like $80 a month. And also, Particle is open source, so if they go out of business, you just load their code on a server and you do it yourself. So same thing with the firmware and the circuit and everything. It's all open source. So if anything, you're not tied. If they go out of business, they get tons of venture capital money. So like they're doing great, and I predict they're always going to like kick ass because they're like amazing. But there's always that risk. You see all these fly-by-night companies, and so I really like their approach of making hardware open source, cloud, open source. It's all open source, but they just make it so easy to use and so cheap to use. Why wouldn't you use their cloud? It's $80 a month, and you know, if you're paying an hourly rate to code something, it's going to be way more than the $80 a month, and so you just go with what they work through all the issues and everything. So that's the Barbarian too. That I was talking about how I love the Barbarian gates. And we also built a, so we wanted to make this thing easy. We wanted to make it so that the electricians and the machine repair people wouldn't have to call us when there's issues, and they can put them on the machine. And so what we do is, when this thing first is connected, it connects into IoT Hub, and like says, "Who am I?" IoT Hub will say, "Oh, this one's new. I don't know who you are." Flash orange, and then on the cell phone, the mobile phone, it'll be like, "Which one are you?" Because you can have like 5 different people install them at once. So like, I'm the one blinking orange. Which color am I? Say I'm orange, and then you can figure I'm on this machine and I'm monitoring these spindles. Made it real simple for them so that they don't have to call us. Because we hate support. So OPC UA is like a common way that everyone's doing this type of thing. Everyone advertises this is like the manufacturing way of doing it. But this works if you have like a greenfield system and whatnot. And for like what we did, it's all brownfield, and we've got tons of different PLCs. Most of them, none of them. They had like 2 PLCs in the whole factory that were connected, so they're not connected. And so coming up with a hardware solution for something that's $50 each machine that can monitor 24 spindles is way better than trying to replace all the PLCs. You know, making sure they understand OPC UA and all that headache. But some solutions, OPC UA is the way to go, and it's all dependent on like new machines that all know it, or not even new machines, but machines that already know OPC UA. Then yeah. Okay, that promo code is no longer valid, but they gave us a promo code. That was pretty cool. Oh, and I only brought one case study because I can't get them all out, but if anyone wants a case study, I've got one of them on this solution here that they wrote up on their website. We talked a little bit earlier about segmentation. So there's more than one type of segmentation. Earlier we talked about the network, and they have 2 networks at home. But there's also segmentation of the logic. Like, we didn't try to control the machine with the microcontroller, because if you hack the microcontroller, you can hurt somebody. You make bad quality, something like that. So the microcontroller is doing its job. It's doing data collection. There's another brain on it. In this case, it's the PLC that's doing its job. It's not connected. Can't hurt anybody, and so it's really good to segment the solution that way. I know security is like key to this group. Everyone thinks about security. And when I was tinkering around like 8 years ago, I thought I was clever. I come up with my own security. That's what engineers do. They come up with their own ideas. And I was like less clever than I thought, because when I came up with my idea, I posted it, made it open source. And like, so now people can really hack it, and it wasn't like a hard algorithm or something that is impossible to crack. So
if your name isn't Diffie Hellman.
Yeah, that's right. Yeah. So I learned the lesson. Don't be clever. Use the shit that's out there. There's amazing open source stuff that's out there, and people and teams have put a lot of brains to it to make it like really secure. So open standards, like a great time to be alive. Leverage their stuff, and not just for security, but for features and everything else. You can really make things really quick. Here's PowerBI. We talked earlier about how I was saying it was kind of lacking, but you can see like some gauges and charts, and you can see real time the data updating. But it's if you want to do like something beyond this, it's really hard to do with the existing streaming analytics in PowerBI, and we had to build our own. So here's how this stuff works. I showed the video earlier of the fog bubbles, and that's what this is about. So Echo talks to Lambda services in the cloud. The Lambda services then talk to the particle cloud, which sends a message down to the microcontroller. And there's code that's living here that I wrote, and then code that's living on the microcontroller. And if you guys want to see the code, I can like raise your hand if you even care about code. Oh, I was expecting like 0 hands. All right. And do you guys want to see cloud code, or do you want to see embedded code, or do you want to see like both? All right. So we'll start in the cloud.
So is the particle just basically a gateway then?
No, the particle is the microcontroller. So there's C code.
So you said there was code on the device,
Yeah.
and in AWS, but not in the particle cloud.
Oh, right. So the particle cloud, I didn't have to write code. They already have an API that you can invoke the API, and it'll send
So
a
it's just
message.
handing off from one to the other.
Yeah, so that's another thing that they do to make it easy. And so, like, I do these projects in a few hours just because you get so much goodness from things like Particle, or I'm using Microsoft. Out of the box, you can really like leverage it and do amazing stuff. So let me first go to the developer console with Alexa. Should have loaded this during the break.
So are you using, I see it down there, Visual Studio Code?
Yeah, I really like Visual Studio Code, but I'm using it more on front-end stuff like Angular type work. All right. So, keeps on updating.
Did you all think about like bringing that to market, like to sell that in production? Because it's pretty cool. I've never seen it on
Oh, it's like, I don't know, once you post it and make it open source, then it's no longer patentable or anything like that, which my wife is like always like asking, like at first she's like, well, why are you spending all your time building this shit? And then she's like, why don't you patent all that stuff? Because like I was doing all the IoT things with like Garage Door, Squirt Gun, way before the commercial products were out. And but it actually ended up being really good because it's how people come to like know the company and know me and things like that. And
So
just,
more of the presence of what you've done out there.
it's more of a marketing
capability.
thing,
Yeah.
marketing tool than trying to make money on it. But here's the circuit and how it works. But I can show you the code. Okay, my internet connection is really slow.
Connect to
How did you do your drawing there? Is that
What's the password?
MS Event 266IA.
Okay.
Oh, Lord.
Okay. MS
Yes.
Yes.
And there's a portal too. So that's in the portal. Now go ahead and try
Oh, I already had the password cached.
Yeah, see, that's you trying to get to the portal, trust me. You need to go to the portal.
Oh,
There's a log on portal that you have to get
yeah,
the
the
password.
from his machine. What do I do?
Go anywhere, and it'll say, you'll get the error, and then hit advanced, come down, and you got to get to it. Man, you can use them. What's the ignore command? This is type this is unsafe. Not there, but inside that page right there.
Where?
Right there. Just type this is unsafe. And then it works for there you go.
Are you kidding me?
I'm serious. Event attendee code. Yeah, that's the bypass if you're wondering. It's MS event, MSEVENT.
All lowercase?
Yeah. 266IA.
Sweet.
Yeah. So, yeah, that's a little known.
Awesome.
That should speak you.
What'd you use to make your drawing up above?
The what?
What'd you use to make your drawing up above?
Oh, the circuit.
Yeah.
A tool called Fritzing.
Okay.
It's open source. Everyone uses it to do like breadboards and things like that. But you can get the components. I didn't like add the bait to it, but the fan and some of the other things they already had, like the MOSFETs. They already had.
Okay.
All right, let me try the developer console again. Ah. Okay, so here's the fog bubble.
Better?
Yeah, this is like a night and day difference. Okay, so this is way different than the last time I was here. Let's see if I can go to like the. You configure the intents that are all JSON. But it looks like they made a UI now. You don't even see the JSON. But before you would, I haven't been here in a long time, but you basically, each thing you wanted to do, you write an intent for, and then if you say make fog bubbles or say hello or happy Halloween, it's going to call this intent. I should have. Where's the code? Okay. Forgot there's a two-step process. You configure all the intents in the Alexa's console, developer console, and then you use Lambda to where you put the code.
So what is Lambda?
So have you heard of like Azure functions?
Yeah.
So Lambda is Amazon's equivalent to Azure functions. They're basically just compute functions. You pay for how much CPU you use.
Which is like next to nothing.
It's like a penny or so to control my home automation for Alexa for a month. Okay. So I used to call it Hello Jack is what I was calling when I was first coding it.
Briefly so, right?
Ah.
There it is.
Okay. So here's the code. This is written in Node. You have choices when you're writing Lambda functions. You can even do .NET Core. You can do Node. I did it in JavaScript. And basically, each one of those functions, it's been so long since I even looked at this, but this code here is how it's calling the particle API. It's basically doing an HTTP post with the device ID and then a function. Then when you call the API, then the particle code will take, it'll send a message down to the microcontroller and invoke your function. So you don't have to write any of that code for particle. You just have to call their API with a post.
Right. Authentication.
Yeah, so it's there's a token, and you get the token through the particle.
It's like an API.
So let's see, Halloween fog bubble. Okay, so you can get each. There's two things. There's a token and a device ID, and the token. Let's see.
So does the token belong to you? Just that's your
it's
API
yours.
key.
Yeah, and they could expire it, and then you have to put in a new one in the code. And then the device ID is each device has an ID, but you basically just get the token and then you put it into your header and you call it.
I like root subroutines without catching on fire.
Yeah. So this is if you want to make something that has a lot of different intents. Like I made an intent to move the server down or move the servo up, turn the fan on, turn the fan off. And then so that's where the Alexa skill kit was good. But normally I would use this smart home API that you have to program OAuth, and it's a lot more sophisticated. But then you can say turn on the fog bubbles, and then you can use routines to add natural language to it, to be like trick or treat or something like that. That's a lot more natural language. And if you want to do that, then so like here's the fog bubble code. This is the embedded code. There's really not a lot to it. You gotta love things like Spitfire, make smoke. But basically, I set up all the particle functions, and then you call it through the API, and then it just invokes your function, which is just C code. It's real simple. Let me show you the Ghost. I showed you the Ghost earlier, but compare how much simpler the Ghost is. Halloween Ghost, where are you? Up here. No, that's my fault. That's the device. The device is good. So here's the up-down Ghost, and basically include this library that we wrote from Charlotte IoT, and this is the Echo Photon Bridge class, and then you can just add a device, Ghost. If you say, Alexa, discover devices, she'll see one that's called Ghost. And then when she does, she'll call this function on-off. And then here's the function. It's real simple. That this just changes the color. So there is no UI on the device, and so for anything, I usually just change the RGB, and it's a red, green, blue. So if you guys do like hex colors, this is just the red, green, blue, just like that. And I also usually put a heartbeat in a loop so that you can see that it's not hung and that it's connected. And so like this is red, green, so this will be all green and then no green. So it's just going to blink green on and green off when you know it's working. And then when you invoke it, it's going to turn red. And then when it turns red, all it's going to do is take one of the pins and make it high. And it's going to make it high for a second. So it's real simple.
Which is the lift for the motor.
Yeah, so it actually just triggers the circuit that came with the device. So it's real small code, and but what makes it really small is using Charlotte IoT stuff. And if you guys know Jeremy Prophet, he's one of the leaders in Charlotte IoT on our board. He wrote the Echo Photon Bridge for our hackathon. It's like really good stuff. Do you guys want to see anything else or have any questions? Yeah.
How would you, if you want to get like, there's a bunch of different things out there. If you want to get somebody young, like thinking about it, involved with it, do you have any suggestions on it? Yeah, your kids involved with it.
Yeah, the Adafruit Circuit Playground.
Okay.
It's really simple, and basically it's a ring with LEDs on it, and you use block programming for it. and then you basically copy it to the device as if it's a USB drive. So if you can copy a file using a USB drive, you can use it. The kids will have like luck building things really quickly that light up and do things. And like we go to the Maker Faire Discovery Place, and we used to teach like really hard labs that were made for like this kind of crowd who's been with computers and IT forever. And we just like floundered our first year when we were trying to do like a really hard lab, and so we switched it up to the circuit playground, and now all of a sudden people with no experience with electronics, no coding background, are able to do like really cool things with the native-free circuit playground. It's really good.
And it doesn't trigger like if they get an interest then in like the programming or the electronics?
Yeah, you're doing block programming, so it's like it helps you think, but it's not like real code like this is C code. For me, the pure joy is in the C code, but if you just want to get someone like building something that they can be successful at without a lot of effort, then that's a great way to do it, and then it can kind of be like a stepping stone into building some really cool things.
So that code's assigned to the device, right?
Yeah, and the device is called Ghost. So I could say, Alexa, turn Ghost on.
Okay.
Now, where are your lights? Which lights were flashing that you can find here?
Oh, so
Those are blue, right?
yeah, those are blue. So what I actually did was, the reason I was able to do this in like 2 hours is I purchased the Ghost from Lowe's that already had lights and it had the motors in it. And it had a button on it that you push the button to trigger for the demo. So all that was
Just wired into the button?
I just wired into the button.
Yes. Okay.
Yeah, so it was a 2-hour project, literally. And just leverage some code from Charlotte IoT and I'm done. Yeah, any other questions? Yeah.
Where do you, I mean, I know you mentioned the particle as far as for the boards. What about like sensors? Where do you normally go to for that? I know it's kind of agnostic, right?
Yeah, there's a lot of great places. SparkFun's really popular for makers. I go to Maker Shed sometimes. I go to Amazon a lot just because I like to use Prime shipping. If I'm just getting like a transistor or something like that, then I usually just do it from Amazon to get overnight shipping. But SparkFun is awesome. And one of the cool projects, I bought a motor controller from them, and it's got the SparkFun. Spark, as in fire. And so like the motor controller has the little spark on it, and I use it to control my fireplace solenoid to like turn it on and off. And I just love that it has a spark on it. But you can get all kinds of really cool things from SparkFun. And I'm working on some really fun projects now. One is a boat in the pool that's using LiDAR that sees where the edge is, and it's going to do concentric circles in the pool to skim it. I'm doing another one where I've got beacons on the animals, and I laser cut acrylic so that when they come to their food, it opens up. So the dog can only eat the dog food, the cat can eat the cat food, and they can't eat the other's food. But it also then is, what time did you eat? How long did you eat? How many times in the day did you eat? And on the scoop, I put a beacon on the scoop, so did someone feed you? If we're on vacation, we can check the log, did someone feed the animals? So all this stuff is like pretty easy and pretty fun. And but if you want to do like predicting health, like use all that data, is my dog sick or not? You're going to need a whole bunch of animals, not just like one dog to do it with. And,
Sample size problem with
yeah, so I've got a problem. I've got to make a product and then sell it to people to do that. But otherwise, the machine learning can't really make any predictions. You can just have fun doing things, but nothing real. Any other questions? Yeah.
You mentioned like the BLE integration and stuff there. Those tokens, they've gotten so inexpensive right now. Are you getting those anywhere, or are there certain ones that
No.
And is Bluetooth still like, is that viable going forward for IoT? Or?
Oh, hell yeah. So there's Bluetooth 5. It's they have new standards. Like cell phones don't even implement all the standards of Bluetooth. And there's a whole bunch of really good companies around Bluetooth. Nordic Semiconductor, you can buy their stuff, and if you use Bluetooth any project. They're more like enterprise type things, but there's lots of others. Nordic, they actually have like some of the patents around Bluetooth, so I always just say they invented Bluetooth. They have salespeople that are in Atlanta, not too far from here, and they're a real good company.
They have Bluetooth that can go to 2 kilometers on a perfect situation.
Listen, there's certain things I heard about, like, I got into it a little bit, and then I kind of faded out of it. But like I was hearing where like Apple had patents to make these BLE tokens that were like less than a penny in cost, and they were going to barcode everything. And I'm just, I heard so much about it like 3 or 4 years ago, and then the adaption's been kind of slow on some of that stuff, it seems like.
Yeah, I haven't seen anything that's been that cheap, but yeah, there's a lot of crap out there, but there's you can make some awesome stuff with some of the crap.
Well, you know, I work in telecommunications, so AT&T's like, they're deploying like a whole network based around their other things. So they've already started doing it. So like Greensboro, I was up there talking to folks who call it like the LoRa network. And I think it's really just using like, so we got 4G, about to be 5G, it's like 2G technology.
The LoRa is a little bit different. LoRa, you can get like 20 miles through an antenna. Right. And I can get a microcontroller that looks real similar to this with the LoRa antenna on it.
Right.
And if it's like open space, you can get, they advertise like 20 miles, but you can get, we'll just say a mile plus on it. And they're making a LoRa Alliance towers in certain cities. Charlotte only has one that I know of, and I don't even know if it's part of an alliance. But like Chicago and some of the bigger cities, they have the whole city lit up. And what the idea is you can buy like a washing machine or something that's already connected, so you don't have the barrier of how do you configure your SSID and password to it. It's already on the LoRa Alliance network.
Yeah, it's really, which is the same one, like that in Greensboro. They're like, what?
It's sweet.
Oh, wow.
Yeah, and then LoRa works really good if you're on a farm. Someone mentioned farming earlier. A lot of times what people do is put an antenna up on the like the silo for the grain or something like that, and it can cover 20 miles or the whole farm with any devices, and you can have solar panels and things like that. Really cool. So a lot of my like Halloween stuff, it's all solar powered. Like the monsters up in the trees, and they charge batteries at night. And, I've got like 6 or so things that are solar powered that are kind of fun to play with. But you combine LoRa with solar, and you've got like all kinds of neat things you can do on a farm.
How you got your medicine there too? Are you using any specific batteries that you like that are working well?
Yeah, for that it has to be plugged in, and I use a micro USB cable. So that's like the negative to it. It kind of sucks that you have to have it plugged in because Wi-Fi uses a lot of power. Yeah.
Is it psychotic medication?
Psychotic? Yes. It is, yeah. No, I probably could use some psychotic medication. Any other things? Yeah, awesome. So why don't we call this a meeting, and if you want to see more code or more discussion, please come talk to me.
What were the dates that you were...
what'd you say?
What were the dates for your next upcoming meeting?
Exactly what I wanted to say. So you guys don't want to miss December 4th. The guy is a rock star from Azure, IoT. He is like the face from Microsoft on Channel 9. He's done more than 100 episodes on IoT for focusing on Azure IoT. You guys don't want to miss it. December 4th here. Thank you.
All right. Very cool. Okay.